We're now going to examine some examples from chapter 4. We want to read the problems carefully. The word of means times. The word is means equals. Okay. Suppose that a teenager spends $20, which is, this is 1/2 of his total savings, M. How much money did he have in the beginning? How much did he have in his savings account? Well, it says 20. That is equivalent to equals 1/2 of times his total savings, M. So there's the translation. 20 equals 1/2 M. Looks like it's answer D. Now to solve this equation, since the coefficient of M is a fraction 1/2, we multiply both sides of the equation by the reciprocal of 1/2, which is 2/1. Doing that on the left side, 2/1 times 20 is 40. On the right-hand side, 2/1 times 1/2. They cancel, give me the value M. Another problem we want to look at is maybe translating an expression into an equation and solving it. The expression says 6 less than n is 13. Again, read carefully. Less than means smaller than something else. So 6 must be less than something else. It's not 6 minus, it's 6 taken away from the value n, or that's something else. So n minus 6 is 13. The way we solve this problem is we add the opposite of -6 plus 6 to both sides. On the left side, that's n plus 0. On the right-hand side, it's 13 plus 6. Notice that when we add the same thing to both sides, the number -6 is gone from the left. It's gone from the left side. But when it shows up on the right-hand side, it's always the opposite. So that's a little quicker way of doing the problem. Just make the -6 disappear. Let's leave the n. But when you write the opposite of -6 on the right-hand side, and that gives me the answer of 19. That's just a little faster way of doing things. Lastly, let's see what we need to do. Let's evaluate an expression. This is going to be helpful when we get to graphing. Here we have a table where the x values are given, 3, 6, 9, 12. The expression is 2/3 times x. We want to find out what that is equivalent to for each of these values of x. So we're going to replace the variable in the expression by the given values, and then we're going to simplify. So when x equals 3, we replace the x by 3, so it's 2/3 times 3. We can reduce, that gives us an answer of 2. So when x is 3, the value of the expression is 2. Let's try it again when x is 6. 2/3, replace the x by 6. Let's reduce first. 3 and a 6 is 2. Calculate, 2 times 2 is 4. So when x is 6, the value of the expression is 4. How about x equals 9? 2/3 times the value of x replaced by 9, x replaced by 9. Reduce first. 3 to 9 is 3. The answer is 6. In chapter on graphing, this is going to be like when x is 9, y is 6, which is going to be an ordered pair or a point on the graph. Lastly, if x equals 12, replace the x by 12. Reduce, 3 to 12 is 4. 4 times 2 is 8. The value of the expression is 8 when x is 12. Referring to the graphing situation, when x is 12, y is 8.